Hello, everyone. Good morning, good afternoon, good evening to all of you. Just a couple of questions before we proceed further. Do you have large amounts of text data to process? Do you find expensive and challenging to convert unstructured data into structured data? Do you want to achieve higher operational efficiency and customer satisfaction? Then you are at the right place. I welcome you all to the webinar on unleashing AI and text data for better BI. I am Neil, the product manager of Text.ai, a product of Indium Software. Along with me, I have my colleague, Mr. Ashish Kumar, principal data scientist, and this is his brainchild, Text.ai. Let us begin a basic introduction to different aspects of unstructured data and structured data as well as text data. Right? This is how our agenda looks like. We'll talk about a bit on unstructured data and its significance. Then we'll talk about the challenges associated with unstructured data. We'll see how to tackle these so-called complex unstructured data. We'll also look at different technologies and a few use cases. I hope you all are very much interested to know how more about unstructured data and how to tackle it. First, the basic question: what is unstructured data? To me, it's just raw data that is not easily categorized in the relational databases, right? Basically, it's like everything that cannot be put into a row or a column. That needs special attention, right? When we look at structured data, for example, transactional data, it is very rigid, right? And we can fit into mainstream databases. But when we look at unstructured data, it exists in different formats. It could be in the form of text, it could be in the form of documents, emails, transcripts, reviews, right? The sources can be varied thanks to digital revolution, right? Social media is generating large amounts of text data, completely unstructured. We can look at scanned documents, machine data. All the machines are generating a lot of data nowadays. IoT, the Internet of Things, social media, and more, right? Organizations use various solutions like big data to store large amounts of unstructured data. That's good. So you are able to store this data, but what are you doing with it? Is it so important to look at unstructured data and see what we can do about it? What is the significance of unstructured data? It is estimated to grow at 50% each year, right, as per Gartner's 2018 Magic Quadrant. And it is also expected to contain valuable information. When I drill down deep inside the reviews and feedback provided by my customers, I would be able to sense them better. I would be able to understand their requirements better. And I would be able to mold my products and services in such a way that I can retain my customers and attract new customers. Right? That is just one side of it. But it is also important for organizations and corporates to structure this data and analyze it so that they can understand the market dynamics in a much advanced way, and they can get deeper insights into what is it that the customers are looking for. So what is the solution to this? Can we do that manually, right? Can we have a large team who can go through lakhs and lakhs of documents or TBs and TBs of text data, right? So automating conversion of unstructured data into structured data is a solution. It will help streamline my processes and it will increase my operational efficiency. And it will also help my team members get rid of all the non-value adding activities and focus on the core activities which actually adds value. Right? So that is where the focus area is. Two aspects to it. One, I can understand the market dynamics, I can understand the requirements, I can understand the customer sentiment, etc. The other one, I can improve my operational efficiency, I can reduce my operational costs, I can automate a lot of processes, which are again tied back to the main objective of customer satisfaction and experience. Right? That is why dealing with unstructured data is very essential. But what are the usual challenges that are associated with unstructured data? Right? Existing systems cannot analyze unstructured data, obviously. If you look at any mainstream analytics products, you need the data to be in the form of quantitative data, in the form of numbers, right? It's very difficult to analyze it straight out of the box. There is no predefined data models. It's difficult to search. And on top of that, not all unstructured data is relevant. We have to select a particular section of data which is very important to me and which makes sense to me and with which I can act upon it. Can I collect this data very easily? No, because it is available in numerous formats. Manual conversion of unstructured data and structured data is very hard, very difficult, and it takes time, and perhaps it takes months or even weeks, and I have to spend a lot on top of that, right? So these are the main challenges that we have to overcome to fully utilize the strength of unstructured data. So intelligent automation is a solution to tackle unstructured data. By intelligent automation, I mean the ability to understand the context and intent of the data and make sense out of it automatically, right? When I train my models, when I train my machines to fetch the data, structure it, and analyze it automatically, that is what the sweet spot is, and that is what we are aiming to achieve, and that is what is called intelligent automation, right? Adding intelligence to the machines and making them automatically analyze the data, right? Here are a few automation opportunities that we have seen in different domains, but this is not a exhaustive list, right? But if you look at banking, you have know your customer, loan applications, accounts receivable and payable. All these processes involve a lot of documentation. If you look at retail, we have voice of customer, where we analyze a huge amount of customer reviews, feedback from various sources such as social media or app store or play store, Facebook, Twitter, etc., even Google. Right? It can be in the form of surveys. A lot of companies do very pinpointed the surveys for understanding the customer needs. When we collect all this data and analyze it, right, so we can definitely make sense of what the customers are looking for. If you look at e-commerce industry, we have product categorization, right? Just imagine the plight of people who are manually categorizing millions and millions of products just to ensure that the search on the e-commerce website is very accurate. When just think of automating that activity, like maybe in a few hours, if we can categorize all the products, millions of products automatically, just imagine the uh, amount of effort that is saved. If we look at the logistics sector, we have shipping documents, bill of lading documents, right? We have insurance, claims processing, and many more. But how can we analyze unstructured data? That is the question. Analytics as such, if we look at it, there are two phases. One is collection of data, and another one is analyzing it. So we need to collect the data, structure it. That is phase one. Phase two, when you have the data in structure format, then you can apply all the algorithms on top of that and analyze it, right? But the challenges that we face nowadays is in the phase one, because phase two we have pretty much very good mature products and mature algorithms. But when it comes to phase one, that's where the challenge lies. How do you collect it? How do you structure it? Right. So when I look at it at 10,000 feet level, I need to collect, identify, extract, structure, and analyze. This is the flow of analyzing or tackling unstructured data. Right. Now I would like to invite Ashish to speak on AI, application of AI on unstructured text extraction.
So now we will talk about how do we bring the sense of structure to unstructured data. So as Neil talked about, unstructured data can be in various formats, and one of the so it can be in PDFs, it can be in images, can be in Word files. Some people say JSON, and others are also part of unstructured data, but they have some sense of structure. So we don't consider them for this purpose. We don't consider them as unstructured data. Here we mean, here by unstructured data, we mean PDF documents, Word files, images, and HTML files. So here I would like to tell you about how do you bring structure, some sort of structure to an unstructured data file, because there has to be a method to any madness. So unstructured data might look like madness, but you have to bring in some methods for it to make sense. So if you take one PDF example, a PDF document, for example, then how we go about bringing a structure to it is that we segregate, we break a PDF document in pieces. So what is the first element of a PDF document? So there can be multiple pages. So page is the first unit. And then you go inside a page. Then there can be several kind of components inside a page. There can be a table inside a PDF document. There can be a key value pair, which can also be thought of as a form, and there can be just simple lines and words, and then there can be rest anything else, which is what we call as peripheral data. So one PDF document can be broken into 5 parts. There is a page, and for each page there will be the tabular component, there will be a form component, there will be line component, and there will be peripheral component. So and then we treat each of them separately. So table can be extracted and directly converted to Excel file using some OCR engine. Yeah, and form can also be directly converted to a JSON because it has an inherent key value structure. The toughest part to structure and make sense is the peripheral part and the line part, because they are plain text. So if you just extract it, it doesn't add a lot of value, because sometimes the exact inside, the information that you are looking for is just blended in a lot of text. So just extraction doesn't help much. So for example, you have invoices, and in that there is the party who has raised the invoice and the party who is going to pay for the invoice. And invoices can come in multiple formats, and this information can be anywhere: left, top right, bottom left, bottom right. And but there can be so many variations. Invoice date can be anywhere. Invoice amount can be anywhere. It can be part of tabular data, but it can be part of peripheral data also. So to take care of that, to bring structure to that, is one of the toughest part, uh, we have our organization has mastered, like bringing structure to peripheral data. We use a lot of deep learning methods for bringing structure and training those models to get the information that we want from the peripheral data. So to summarize this slide, one PDF is divided into pages. Each page is divided into tabular, forms, line data, and peripheral data, and each of them is treated separately. Uh, Table is just extracted to CSV, or to a JSON, and the form is directly converted to key value pair, and other peripheral data is structured using deep learning methods like LSTM and CRF. So that is how we bring a structure to a PDF document. And then here, right now, we are talking about the extraction. We are focusing on extraction from PDF documents. So what does extraction module do? As I was telling you earlier, by unstructured data here, we mean PDF files, images, HTML files, Word files. So if you pass them through this extraction module, It will give you the extracted data in a CSV or in a JSON or in an XML file, or it can be written to a database as well. So that's what on a high level extraction module does. So it changes on the basis of the use case, like what is the ultimate use case. That's it will change based on that. What are some of the uh, libraries or tools we use to make such a product which can do extraction, which can do summarization, which can bring a structure to the extracted data. So we use a lot of so our product is built on Python backend, and we use a lot of Python libraries. These are all libraries with copyleft license, so they are free to be used for commercial purposes. And so, if we talk about these libraries, Tabula and Camelot are engines for reading PDF documents. Um, OpenCV is used for processing images. Um, uh, so OpenCV is used a lot for enhancing the quality of images, and by pre-processing, I mean removing the highlighted pieces, removing blur from a document, and so those kind of pre-processing image enhancing techniques is covered in OpenCV. And TensorFlow and Keras are used for implementation of any deep learning method, especially in the so we use deep learning at two places. One is for automatic table identification, where we train table identifier using convolutional neural networks. And the second place we use deep learning, which we implement through TensorFlow and Keras, is for structuring the peripheral data using LSTM and CRF. So, and Beautiful Soup is for handling HTML files and for scraping. Scrapy and Selenium are Selenium is a web automation tool, but here we use it as a tool for automating scraping from web pages. Yeah, so coming to reference architecture, so this is like a list of components which can be, it is the reference architecture of our product as well, but it can be kind of a template architecture for any such solution which we want to create for text extraction. So there is the core is ML and machine learning and deep learning. That is the core engine. As I said, two main things, which is stable identification and structuring of peripheral data. They are two big tasks that we perform for making sense of any unstructured data. So that happens in this ML core. So there are different components of that ML code. There is IO input output of the different kind of files, PDFs, images, Word files. So that is IO. Then there is pre-processing, in which we use OpenCV, DSQ, PIL, DWOP. There are very scikit image. These are all the libraries to work with images. So what happens is, any kind of document, we first convert to image and then OCR. So OCR is uh, OCR works when you have when you convert it to image, and pre-processing, you can perform pre-processing as well when you convert it to image. We convert all kind of documents to images first, and then apply pre-processing using these packages. Then there is OCR engine, where once it is converted to image, then we need to read it as plain text. So that is the OCR. Some people say that OCR is so it is not just OCR. What we are doing is not just OCR. There is pre-processing before it. And then there is tabular extraction. We are separating tabular and peripheral, and we are structuring the peripheral data as well. So it's not just OCR. When we talk about table extraction, or when we talk about document extraction or text extraction, we are not just talking about OCR. It's just OCR is not very useful. You have to bring the structure even after OCR. So these are the components for ML core, and on top of that, so this is all converted as a microservice architecture. Like IO is one component of that microservice architecture, pre-processing, OCR, tabular data extraction, and peripheral extraction. They're all different components of that microservice architecture, and they call one another. So, and this is all contained in uh, uh, separate dockers. And then it is on top of that, there is these are all converted to APIs, Django APIs, and then they are called, and then there is a load balancer to take care of multiple users, concurrent users, so it can assign different deployments in the server. And right, our product is deployed on GCP right now. The UI on top of that is built in JavaScript. We use different kinds of JavaScript. There's Angular and Edge and Canvas being the main ones. And then there is standard product development stuff, like there is authorization system for new users. And on this side, you can see there are a lot of databases. So they are to take care of the document metadata and the user metadata, like who ran which document, and just for log sake, and for also persisting the data in memory, like someone has run a big file and it takes some time, so you don't want to redo the process, and you can download it if someone has already done it. So those kind of things. So for that, we need databases. For that purpose, we use MongoDB, and for caching, we use Redis. So that's on a high level the reference architecture. Yeah, so now I think Neil will take over again for talking about some use cases.
Let us quickly look at a few use cases and how we can tackle these use cases, right? When we talk about claims processing, we'll have different types of documents. It could be policy document, receipts, bills, claim forms, etc., right? The high level solution flow should be to achieve the intelligent automation status, right? We have to first identify the document. So the problem in this domain is there is no one size that fits, one solution that fits all the sizes. So that's the problem, right? So first we have to identify the type of document. So we have to ensure, okay, which is the right model for this, right? And as Ashish mentioned, there's pre-processing where we try to enhance the quality of scanned documents or images if necessary, right? So first identify it, apply pre-processing, and then we have to extract the fields of relevance, right, and generate output in preferred format so that it can be directly uploaded into the downstream applications, right? So that's when we achieve the achieve the automation in true sense, and that's how you get the benefit out of it, right? If we can achieve this, we can definitely see an improvement of 20 to 30% in processing time, and also 20 to 25% reduction in operation costs. Other one where there's a lot of pain in extracting the tables from annual reports. This is another use case where we can identify the balance sheets and profit and loss statements in a 100-page or 500-page document and extract it and structure it. On top of that, we can also do post-processing. Basically, we can apply a basic mathematical calculations on the output extracted so that the data points are readily available for an investment banker to analyze the performance of a organization or a company. Right. In the logistics sector, as we already spoke, we have a document called bill of lading. It comes in various formats from various departments and various suppliers and various countries because of regulations, right? This also takes a lot of time in manually extracting the data points of relevance or importance to a particular organization. Another interesting one, and it's a very interesting use case. We have honestly, I have not seen this coming from coming to us from a real estate sector, right? So they have a lot of deed documents, and we have to identify the plot directions and the plot latitude and longitudes of a plot from a 40-page or 100-page deed document, and structure it in a way that they can use it directly to for creation of a blueprint or something of those sorts, right? So this is a very interesting use case, and we have been partnering with this organization to achieve the automation, and it's pretty good at it. Another complex one is scanned engineering diagrams. Right, when we look at the document on the right hand side, we have to extract the tables. Basically, we call these as nested tables. It means a table within a table, right? So that's a big another challenge, because the columns, number of columns vary from table to table. It's not consistent. So again, we can't predefine the coordinates, or we can't predefine the structure of a table, right? So we have to first segregate these tables and then extract it, right? So this is also another interesting and complex extraction that we have done so far. So coming to there are different products in the market that can tackle unstructured data. So we are also one of them, and so we are called AI. Simply put, it's text analytics using AI. So we have three major modules for extraction, classification, and summarization. And the focus of this webinar is only on extraction. So we'll just talk about extraction. So Ashley has already spoken about the technology and the algorithms that we have used. So these are the high level features that we have. We support multiple languages. We support both peripheral and tabular data. We handle complex business needs, because as far as we are concerned, there will be a bit of customization for depending on the document type, right? So without customization, it would be very difficult. There cannot be an off-the-shelf API or a product that can solve or extract data from all the document types that we have in the industry, right? So before we get into question and answers, let us extract data from a few documents, which will help us in understanding how will it be helpful to the people, right? Let me log into our product. So these are the three modules, and let me go to extraction. Okay, before extracting the data, from data from documents, let us look at pre-processing. It's another interesting module, uh, which basically enhances the quality of any image scanned one. Let me select a few techniques. These are the techniques which have been inbuilt. Obviously, there are many more techniques. So we look at the documents and then decide what all techniques we have to apply. So these four are the commonly used techniques for pre-processing, but it is not limited to these four. So the best feature of this is to compare the input and output side by side, so which will give us a sense of the improvement. If you look at the input document, it is skewed, and there is the data is smudged. And if you look at the right hand side, which is pre-processed image, it is much more brighter, and then the contrast is increased, and the alignment is also rectified. So basically, this will help the extraction module in extracting the data accurately. And as far as we have seen, we can improve the quality of an image or a scanned document by 15 to 20% using our pre-processing module. That is an average a percentage number that I'm quoting, so which will definitely improve the quality of extraction as well, right? Now let us look at extracting data from a few files. So basically, we have different options to get the data from. It can be S3 bucket, Google Drive, or OneDrive. Doesn't matter. So we have options to directly fetch the data. Let me feed one document, scanned one, and run it. So when we run these files in a batch mode, the method will be automatically selected. So that there is a heuristics algorithm that selects the right method when we run it in the batch method. So when we are showing a demo, we just want to be as transparent as we can, and so we just want to show you the different methods that we use, and we also wanted to give flexibility to a few technical people who were interested in looking at and playing around with different methods. So that's how we have enabled that single file option. And this is the data, the scanned one, and the data is available on the right hand side. So basically, we can compare with the table viscosity 283, 225 to 425 MPas, right? So the best feature is that this has been created to make the life of a QC simpler, because obviously in the initial stages of deployment of any product, right, we want a human to be in the loop just to ensure that the product is working as expected, and also we are meeting the accuracy expectations, right? If by chance, if it is not extracted properly, there is always a chance or a feature to just change it, like to edit it and then save it. So this will be reflected in the output once I download this the results, right? So that's how it makes the life of a quality analyst simpler and easier, right? And we also have OCR confidence score, which will definitely which has a threshold value which is customizable depending upon the training set and also the comfort levels of our customers, right? Only if the confidence score falls below the threshold value, those files can be checked manually. Else, it can be straight through automation and extraction. So there is no need for any quality analyst to check those files. And other modules are a report section where we have all the files that have been extracted, the date and time elapsed, and number of files. So this basically helps us in meeting the regulatory complaints and all the other stuff on any audits. We also have user logs. So basically to just to have a check on the internal and external audits, right? So that's about uh, handling the unstructured data, and this is how we handle with AI. And okay, so that's all about we want to talk in this webinar, and the floor is open for questions. We'll be happy to take. Okay, yeah. So Ashish, we have a question here. So how many documents are required to train any specific document? Say for example, if I want to uh, extract both peripheral as well as tabular data.
So it depends on use case to use case basis. If your document has only tabular data, then it doesn't need a lot of training. Our Because one table is very similar, so we have trained it on a very large set, and it at the end of the day it's the same task of identifying table. So we have a model that we have trained which can identify tables. So there is not much of training required for that. So if your PDF document or image only has images, good quality images, we don't need any training for tabular data. The training is needed to extract data from peripheral part, and that is required because every peripheral data is different. If it is from invoice, it will be different. If it is from bill of lading, it will be different. If it is from a deep document, it will be different. So, and we are looking for different things. You are looking for invoice date, invoiced company, and all those things. But in a deep document, you are looking for totally different things. So that's why training is needed every time, and to give and that is where we train and the LSTM and CRF model for um, custom entity detector. Like we identify the entities. That's how we fit keys to the values. So for that purpose, to give a baseline model, around 50 to 100 documents or pages are enough to start with a baseline model, right? So we can create a baseline model, and then what we have is auto training. So when user starts to use that system and correct it and all that, so next document and the further documents, they start becoming part of the training data, and they get trained again. So the baseline model keeps improving after that. So to start with, around 50 to 100 is a good number to create a baseline model.
Here is the second question. So how much time will it take to customize? Say, for example, as you said, we need to train for each and every document type, especially if we have to extract data for peripheral data points. So,
Mhm.
question, like how much time will it take to customize for a specific document type?
So customization is determined by two, three factors. One is this training. So this is quick. This can be done in like 3-4 days, because and that too because the tables, the data needs to be annotated for training. So otherwise the process, the algorithm, the code flow, the pipeline, everything is ready with us. So the training customization is quick, but the annotation takes time. So that can be done in 3-4 days, but that is one of the determining factors for customization effort. There are other components like what is your input process. Is it through a API? Is it through a Google Drive or S3? We have inbuilt support for S3 and Google Drive, and but if it is an API, custom API, that through that you are throwing this document, or is there a email process flow? You're sending it to one email and we need to read it from there, or there's a queuing system from which we need to receive and then process. So if those kind of things are there, that also goes into customization, and also depends on output. So if you want just JSON, simple JSON, then or XML, then it doesn't take a lot of time. We already have built-in support for that. But if you want to write it to a database, or if you want to write to a file system, so that might take some time. So 7-8 days, 2 weeks, that's a good amount of time, but it can also go up to 3-4 weeks depending on the input and output.
Here's the final question. How is text.ai different from the normal OCR? There are a lot of OCR products in the market. So what makes text.ai different from the usual OCR?
So yeah, as I said, OCR is when people talk about text extraction, I have come across a lot of people who just think OCR. So OCR is the process of reading text from an image. That is optical character recognition. It just reads from an image and converts it into an editable format. So that is just that is OCR. But when you want to extract data in a usable format from a PDF, then that's not just OCR. Because if that was the problem, then you could just OCR and use the data as it is. But the main pain point is that you want to segregate the tables and you want to segregate the peripheral data, and then bring structure in that peripheral data also. So just OCR doesn't solve the problem. So for us, the USP is our expertise in bringing structure to peripheral data. Many people take computer vision approach. We take NLP approach to solve this, and this is we get very good results on when we structure it using our module. Especially, we have gotten good results from clients in retail, real estate, and manufacturing domains. So that is one, and the second is our specialty in handling very complex documents. We showed some pre-processing module methods to you. They take care of a lot of scenarios, and we have seen a lot of files which we handle a lot of files from our customers who went to all the existing tools, but they drew a blank. Those tools drew a blank because they needed some customization, some hardcore pre-processing. Some were blurred, some were nested tables. So none of the tools had inbuilt support for all those kind of variations. So but with help of little bit of customization using more hardcore computer vision pre-processing. We were able to get good results on those very complex documents, especially nested tables, and highlighted PDF documents. These very tough complex documents that we have handled. So ability to handle peripheral data very well, and ability to handle very complex documents. So these are, I would say, are and that brings to the point of customizability, high customizability. So these are our USPs.
Yeah. Okay, thanks for that, Ashish. Thank you so much, people, for attending this webinar. I hope this rings the right bells. And if you would like to have another conversation with us, you are welcome to visit us at www.text-ai.com, or you can also connect with us over LinkedIn. We have text.ai handles, right? Or you can just email us. Thank you so much. Interesting questions, and I hope you enjoyed the discussion and you enjoyed the webinar. Thank you.